morning. In the last class we have seen how to develop a force vector once we are given the coordinates of points between which the force is acting. So first find out the direction vector, unit vector in the direction of the force, magnitude of force multiplied with the unit vector will give us the force vector. Then the components of the force vector, fxi plus fy plus fij plus fzk will give you fx, fy, fz, the components, and based on that we can find out the direction cosines L, M and N, or cos theta x, cos theta y, cos theta z. Now we are going to discuss the how to find out the resultant of a system of concurrent forces. As we have done in 2D analysis, resultant of concurrent force system, there we will be having only fx and fy. Root of fx square plus fy square will give us the resultant. But in three-dimensional force system, suppose there are a number of forces. Each force has to be represented as a vector. A number of forces acting at one particular point in space. So concurrent forces, all the forces are passing through one single point. So F1, F2, F3, say if there are n number of forces, each of these forces are concurrent forces in space. So how will you represent a force in vector representation? Fxi plus Fyj plus Fzk. So the first one, F1, we have given a prefix 1. F1xi, F1yj, F1zk. Similarly, the second force, F2, is designated as with a prefix 2. F2xi, F2yj, F2zk. Similarly, F3, F3xi, F3yj plus F3zk. Suppose we want to find out the resultant. Resultant is find out the vector sum of F1 plus F2 plus F3. So F1 vector, the force vector, F2 the second force vector, the third force vector. So F1 vector plus F2 vector plus F3, sum of the vectors. So what we have to do? Group I terms all together. All the I terms you add first. So it will be F1x plus F2x plus F3x I plus group j terms all together, F1y, F2y, F3y, j plus then all the k terms together, F1z plus F2z plus F3z k, I, j, k. Each of this is vector. So this F1x plus F2x plus F3x, what is it? It is the sum of the x components of all the forces. So for the first force, F1x is the x component, this is x component, x component. So this can be rewritten as sigma fx, sum of x components of the different forces acting at that point into I, plus this is sigma Fy, components of all the forces acting in the y direction, j, plus sigma Fz, j. So sigma, this will put together, sigma fxi, sigma fyj, sigma fz, k. So this can be put together as sigma fxi, sigma fyj, sigma fz, k. Okay, so the resultant R, or it can also be rewritten like this. The sigma fx can be written as Rx, Rxi, the resultant in x direction, the resultant force in y direction, Ryj, the resultant force in z direction, or the component, the resultant of x component. So sigma, sum of the forces in the x direction into I, sum of the force components in the y direction into j, plus Rzk. So from this I can get the magnitude of the resultant. The magnitude of the resultant is nothing but square root of Rx square plus ry square plus rz square. It is nothing but root of sigma fx the whole square plus sigma fy the whole square plus sigma fz the whole square. In two-dimensional system, we are writing r is equal to root of fx square plus fy square. Here there will be fx square, fy square plus fz square. Now the direction cosines. If you want the direction cosines or the directions of the resultant, it's a vector, so you should have mentioned the direction also. Cos theta x is nothing but rx by r. Sigma fx by r or rx by r. Similarly, cos theta y is sigma fy divided by magnitude of r, or we can write it is ry by r. And similarly, cos theta z is sigma fz divided by the modulus of r, or it is rz by r. So the finding out the resultant of concurrent force system is nothing but the vector addition. So r is equal to rxi plus ryj plus rzk, and cos theta x equals rx by r, ry by r, and rz by r. Now let us pass on to a numerical example based on this concept. So let us see a numerical example based on the theory which we have discussed for how to find out the resultant of a system of concurrent forces in space. So I'll read the question. Forces 32 kilonewton, 24 kilonewton, 24 kilonewton and 120 kilonewton are concurrent at origin and are respectively directed through the points whose coordinates are A 216, B 4 minus 2 5, C minus 3 minus 2 1 and D 5 1 minus 2. Determine the resultant of the force system. So it is shown here. Number of forces are passing through this origin 0 0 0. A, B, C, D. The directions of each of these forces 32, 24. These are given. The coordinates of points A, B, C, D are also given. You are asked to find out the resultant of this force system. So what is the first step? The resultant is nothing but vector addition of the four forces. So first step, the resultant R is nothing but vector addition of F1 plus F2 plus F3 plus F4. There are four forces. So our aim is to find out the force vectors F1, F2, F3, F4. Here the magnitude of the force is given. We have to find out the force vector. How will you find out the force vector? If you want to find the force vector F1, F1 will be magnitude of F1 into unit vector in this direction OA. First force is acting in direction OA. So you have to find out the unit vector in the direction OA. So let us write unit vector in direction OA. Lambda OA. How will you find out the unit vector? Unit vector is obtained as XA minus XO. So the second letter is A, the first one is O. So 2 minus 1. That is 2 minus 0. 2 minus 0 I plus 1 minus 0 J plus 6 minus 0 K. So that will be divided by square root of 2 minus 0, 2 square, 1 square plus 6 square. So this is the unit vector. Unit vector in the direction of OA is given by the position vector OA divided by the magnitude of OA. So that will work out to lambda OA unit vector is equal to 2i plus 1j plus 6k divided by 2 plus 1, 3, it works out to okay 0.31i plus 0.156j plus 0.937k. So we get the unit vector in the direction is divided by root 41. This is the unit vector. Therefore, I can write F1. The force vector F1 is equal to magnitude of F1 is 32. 32 into, I'll write once again, the F1 vector is nothing but magnitude of F into unit vector in this direction OA, lambda OA, which will be 32 into 0.31i plus 0.156j plus 0.937k. It works out to 9.92i plus 4.992j plus 29.984k. So this is the first one. We got the first force vector F1. Similarly, I have to get second force vector F2. F2 is nothing but modulus of F2 into, it acts in the direction OB. So we get the unit vector in this direction OB. So I can write it directly. F2, the magnitude of F2 is 24 into unit vector in direction OB. OB means B minus O. So it is 4 minus 0, 4i minus 2 minus 0, minus 2j plus 5k divided by square root of 4 square plus 2 square plus 5 square. So the unit vector is 4 minus 0, minus 2 minus 0, 5 minus 0. So it is 4i minus 2j plus 5k divided by root of 4 square plus 2 square plus 5 square. So this will work out to, we'll get F2 is equal to, after doing this calculation, 14.3i minus 71.5j plus 17.88k. So this is the second one. This is one first force. This is the second force. Similarly, I have to get third one, F3. F3 is equal to modulus F3, the magnitude of F3 into that force acts in direction OC. The unit vector in this direction OC. So that is equal to, the magnitude of the force is 24 into unit vector C minus O. The coordinate of C minus O. So minus 3i minus 2j plus 1k divided by square root 3 square plus 2 square plus 1 square. So it just will, on doing these calculations, we will get F3 is equal to minus 19.25i plus minus, second term is also minus 12.84j plus 6.408k ijk. So this is the third one. Similarly, get the fourth vector F4. F4 is obtained by modulus of fourth vector into unit vector in this direction OD. Unit vector in direction OD. So that is equal to, force vector is 120 into unit vector D minus O. D is 5, 5 minus 0, 5i plus 1j minus 2k divided by, unit vector will be this, divided by root of 5 square plus 1 square plus minus 2 square. It works out to F4 is equal to 109.56 I plus 21.96 J minus 43.8 K. So now from the given data of the coordinates of the 2 points, we have found out the direction vector or unit vector in this direction. The top term is direction vector. This is dividing by the magnitude will be the unit vector in that direction. The magnitude of the force multiplied with the unit vector will give you the force vector. Now we have got F1, F2, F3, F4. All the force vectors we have obtained. Now what is the resultant? The resultant vector is nothing but F1 vector plus F2 vector plus F3 plus F4 vector sum. So group the terms, I terms, 9.92, 14.3, 19.25, 109.56. So I can write down separately F1 X, or I'll write it. I'll write here. Combining the I terms together, 9.92 from the first one, 14.3 from the second one, minus 19.25, 109.56. All the I terms are combined together, I plus, I'll next combine the J terms together, J 4.992 minus 71.5 minus 12.84, 21.96. J terms together. Next combine the K 29.984, 17.88, 6.408, then minus 43.8. I, J, K, all these are vectors. Grouping it together, I'll get R is equal to, the resultant vector is equal to 114.53 I plus 6.96 J plus 10.472 K. So this is the first answer. Resultant vector is 114.53 I plus 6.96 J plus 10.472. This is the resultant vector. If you find the magnitude of resultant is equal to square root 114.53 square plus 6.96 square plus 10.472 square will give you the value 115.29. The unit is kilonewton. So that is the magnitude of the resultant. Now regarding the direction, how will you find the directions? Direction. Cos theta x is equal to sigma fx divided by the resultant, numerical value of the resultant. What is sigma fx? This one. This is sigma fxi plus sigma fyj plus sigma fzk, or rxi plus ryj plus rzk. Either we can write sigma fx by r, or we can write rx by modulus of r. Rx is the first term, 114.53. 114.53 divided by the numerical value 115.29. 115.29, the resultant 115.29. From that you get theta x. You get theta x is equal to 6.28 degree. Similarly, cos theta y is equal to sigma fy divided by f, that is sigma fy divided by r, or ry by r. Both are same. Sigma fy, the second term, 6.96. 6.96 divided by 115.29. From that you will get theta y, 86.54 degree. And similarly, cos theta z is equal to sigma fz divided by mod r, or rz by r. The third term, 10.472. 10.472 divided by 115.29. From that you get theta z, 84.79 degree. You can also make the check. Cos square theta x plus cos square theta y plus cos square theta z is equal to 1. Cos theta x, this term, this, square it and add it, you will get 1. So finding the resultant of concurrent forces is just vector addition of the different force vectors. Okay, we'll stop for the day. In the next session, we will be discussing equilibrium of concurrent forces in space. So, in order for a body to be in equilibrium, the resultant must be equal to 0, or sigma fx should be 0, sigma fy should be 0, and sigma fz should be 0. So, to solve the numerical examples on equilibrium of concurrent forces in space will be dealt in the next video. Thank you.